the steps while you're learning this, that's perfectly fine. You'll get used to it, though, where you won't need to write the steps. Step number 1, again, I like to use x and y's rather than f of x. OK, step number 1, based over there. All I did is I replaced f of x with y. Pretty simple. I'm pretty sure everybody can go and do that.
What's the sign for number 2?
Swap x and y. So step number 2 is you're just going to swap the x and y variables.
Is that and sign?
Yeah, that's the and sign. OK? Everybody got it? I still really haven't done much crazy math stuff. I just replaced f of x with y and swapped them. Step number 3, solve for y. This goes back to your Algebra 1 training. We're just isolating our variable y. Right now, my variable y is being multiplied by 2/3 and being subtracted by 5. So to solve for y, I use my inverse operations. Always undo addition and subtraction first. Now I need to undo multiplication. Right now, I'm being multiplied by 2/3. So I could undo multiplying by 2/3 by dividing by 2/3. But we don't really like dividing fractions. Instead of dividing fractions, we prefer to multiply by its reciprocal. So you multiply by the reciprocal on both sides. Remember, when you're multiplying here, you're multiplying the whole expression by that fraction. So therefore, you have to apply distributive property. So I get 3/2 x plus 15/2, because 3 times 5 is 15. 2 times 1 is 2. And that equals y. Step number 4, replace y with f of x. And I'm going to swap them again. So it's f inverse of x equals. So therefore, this will look like f inverse of x equals 3/2 x plus 15/2. Now, I did ask to find the domain and range, right? So let's find the domain of my original function. Again, can I divide by 0 at all? Is it possible? No. Can I take the square root of a negative number? No. So the domain is pretty simple, all real numbers. Let's look at the range. Again, to find the range is the domain of f inverse. So we go to f inverse. Let's find the domain. We know how to do that algebraically. Can we divide by 0? No. Can we take the square root of a negative number? No. So the range is also all real numbers. All right? Now, what I'm going to do is I'm going to graph both of these so we can verify